This is the standard molar volume of a gas lab. I like to call the Dr. Frankenstein lab. We're going to have all this glassware, tubing, we're going to have bubbling, color changes, all kinds of stuff going on here. So let's get started. So we're going to take 20 mils of 6% hydrogen peroxide. So this is like the hydrogen peroxide you might have at home, except this is quite a bit higher concentration. And getting this on your hand will almost instantly start to burn, so you gotta be careful. But I probably will burn myself. I'll show you the burn if that happens. We'll see. Okay, so that's 20 mils of hydrogen peroxide. And that goes into this reaction vessel that we'll be using, this Erlenmeyer flask. Let's put that there. Okay, so 20 mils of 6% hydrogen peroxide. All right, now we're going to take our iron 3 chloride, that's our catalyst, and we're putting it into this titration vial. And it has a flat bottom to it, which is going to be important to keep it stable, because we want to mix it with the hydrogen peroxide, but we want to pick when that happens. So we want it to be able to sit inside of the flask without falling over until we're ready. I'm going to fill it about a third of the way up. We can put in any amount. I'm going to put the rest of this in the waste. We can put in as much as we want. The more we put in, the faster the reaction is going to go, but about a third of the way is good, and then we know that it's not going to spill over. We don't want to fill it to the tippy top. Now that we have it, we're going to use these big forceps. Got to be careful with this part. Grab this and then put it into the flask. It's a little bit unnerving, but once it's in there, it's sitting flat, it's all set, so we're all set to go. And I should say this, so the hydrogen peroxide is in here. This is going to react with the iron 3 chloride to produce oxygen gas that we're going to collect in our system. But right now, the two are separated and everything is set to go. So we want to weigh the reaction vessel. It has the hydrogen peroxide, and then it has the vial with the iron 3 chloride catalyst. After the reaction is over, the oxygen will be gone, and there will be a significant weight loss. We'll be able to notice it. So we want to weigh it beforehand and then after. So first thing is, oops, I think this just shut off on me. There we go. Put this in carefully. And there is how much it weighs before the reaction occurs. All right, here's the system. I haven't put in the water. We're going to put water in here, but just show you, this is going to be on the reaction vessel. Then we're going to knock the catalyst over. It's going to pour into the hydrogen peroxide. That's going to produce oxygen gas. That's going to come through here up this line and into this flask. And the flask is going to be filled with water. That's going to push the water down and into that lower tube, and then up and into the beaker. And we're going to then, from the water that's collected, we'll know how much oxygen went in here by water displacement. So what we need to do is set this up. First, take this out. So we're going to need water in here. And see here. It's hard to get the whole thing in the shot. Okay, so bring this a little closer. I got this gigantic graduated cylinder. It's a 1,000 mil volume. And this is just tap water that's going in here. And I'm going to fill it up pretty high because you don't want to run out of water. That's the big thing. So if you run out of water and oxygen keeps going in, you're just not going to, it's going to be really bad. So we want to have a lot of water, but it doesn't have to be any particular amount. Just from what I know, that just stopping before we get to the spout here, that's going to do it. Okay, so we're going to put this in. Whoops. And this clamp here is to keep the water from flowing back into the flask. But right now we need to get water into this line. Let's go back up here. Yeah, we need to get water into this line because when the oxygen flows into here, it's going to push down, and if this is air, then the air is just going to go through and it's just going to go into the atmosphere. So we need to have water in the line, and how you do it is you take this and you blow into the end of it. This has been cleaned, but you don't want to touch it. What I normally do, just hold it like this, and then I'm just touching my hand and do this. So just going to blow into it. And should be able to see that water's flowing through here. So all the air that was in this line is gone. So then we clamp this off. Clamp this line off. And then I'm going to, now that the water's not going to flow, I'm just going to get rid of this. So let me get this back here. So all the water all the oxygen that goes in will displace water that will go in here. So all the water that's in this beaker at the end will be due to the oxygen. So it'll be a nice, easy calculation. So we're going to start this reaction. What I'm going to do is just shake this until one good snap should do it, but shake it until that the iron 3 chloride is toppled over and starts mixing. And then as soon as it starts mixing, I'm going to take this clamp off. Get a few seconds, but if you forget to do that, the oxygen gas pressure will build up in here and blow the top of this thing off, so we don't want that to happen. So, but usually it's not a matter of milliseconds here. You have a little time. Okay, so I'm going to just take this, make sure I'm on camera, right, and just do that. And notice it starts to change color instantly, and bubbling is beginning. So I'll take the clamp off and save that for later because we're going to have to clamp it off. And let's see. I'm going to get a little closer here. That's bubbling away. Everything looks like it's working over here. See, the water level is increasing like it should. So there's nothing getting in the way. You can see that the water level is dropping here. It's not as obvious because it's such a large amount of water. And there's the whole system. You gotta be careful, watch that beaker. That should be enough. That's a 600 ml beaker, but if it were to start to overflow, I'd just pour out the extra and save it in another beaker, so we'd be fine. This is pretty dynamic, so this must be nice and fresh hydrogen peroxide gas, or solution, producing a lot of oxygen gas. And notice the color is changing back to that orange. It was a darker color as the reaction is going on, but remember it's a catalyst, so once the reaction is over, the iron 3 chloride goes back to what it was, so it goes back to that same orange color. So I'm going to just shake this up. And we can keep shaking it, keep the reaction going, and that's what I'm going to do for the next couple of minutes here. So let me just draw back. See that we've got quite a bit of water in the beaker now. That reaction is still going. So I'm going to let it go for a little bit longer. Okay, I can see that there's still some bubbles going on, some bubbling. And let that go, and then when it's quite obvious that it's no longer reacting, I'm going to clamp off that tube, and then we'll be ready for the next part. Here's the reaction vessel. There are some bubbles that you can see there, but there's no bubbling. There's no more oxygen being produced. And the color of the solution is back to the color of the original catalyst, the iron 3 chloride. So that's a good sign everything has stopped reacting. Then over here, the water level remained the same for quite a while. And when I took out the hose, no water was flowing, so I clamped that off. And then I put the thermometer in, because that's something that we need, is the temperature. Whoops. Looks like 23.5 degrees Celsius. So that's the next data point we need. Then we need to know the mass of the reaction vessel after the reaction is over, and we also need the barometric pressure. So let's go do that. All right, now we're going to measure the sample, the reaction vessel, I should say, after the reaction. There we go. And see that it has dropped. So the difference that we see there should be due to the loss of the oxygen. So we know now, by difference, we should know what mass of oxygen went into the system. Okay, I said that all we needed was the mass of the reaction vessel after the reaction and then the barometric pressure, but we need one more thing. We need the volume of the water that we collected. That was really the whole point, so we got to do that. We're going to use this graduated cylinder. If you look at the markings, there's 10 markings between the 50 and the 100. So that means that each of those marks is 5 mils. So we're going to have to estimate using that. So let me just go here. And I'm going to add in the water from the beaker. And hopefully we don't go over. Whoa! Let's see. Did we make it? There's the 500 mark there. I would say that you should estimate that at 495 mils for the volume of water collected, which means it was 495 mils of oxygen gas.